Hello everyone and welcome back to my channel Let's Slice Data with Saurabh. So today I'm going to create one video on oil and gas industry, which is a very hot topic, and due to use of AI, Python and AI, it is becoming very hot right now. So everybody is asking about it. If you're going to give any interview in oil and gas industry in the upstream wells and subsurface, basically, they're going to ask you what is NPT, what is why it is happening, what are the main root causes of that, how can we prevent that. So all these kind of questions are going to come to you, and for that I have created this particular video, and I will showcase you one Python use case in the end, which will tell you how can we reduce this NPT and how can we tackle that. So be there in the video till end and try to learn what I'm trying to show you. Okay, so first of all, what is NPT? NPT means non-productive time in the oil field. And NPT anywhere, it is, we are trying to avoid this NPT, non-productive time, whether it is holidays right now are going on, right? You are on leave, you don't have any work, you are not going outside as well because it's a very foggy situation, you cannot drive, you cannot go anywhere, flights are getting cancelled. So basically it's NPT, non-productive time, and that you have to utilize this particular time and think about that if you're losing some money out of it. So NPT is fine, but if you are losing some money out of it, then definitely it is a big, big deal. And in oil and gas industry, if there is NPT in the oil rig, in the oil and gas field, then you are going to lost a lot of money. Money. So for that only we are doing this, drilling exercise, getting the crude oil out of the surface, up to the surface, and then creating these end products like petrol, diesel, all these things, right? So crude oil, getting crude oil from the oil earth is very important. That is the upstream part. And in that, NPT is going to play an important part. And why it is important, how it is important, and how can we reduce it? Let's see that. So in oil and gas industry, non-productive time refers to any period when drilling or production activities are halted due to unplanned events. So any kind of event, if there is a halt in the oil and gas production, that is called NPT, it can cost around 20 to 30% of total drilling cost. It is multi-million dollar I am talking about. So you can see in 2025, non-productive time costs are driven primarily by rig day rates, which have remained high due to tight supply. On average, offshore organizations lose approximately $38 million annually. Think about this money, how big it is due to the unplanned downtime. Downtime is the non-productive time in the oil and gas field. And why it is happening, what kind of factors are included there, I will showcase you in the next slides. But try to understand the impact. $38 million annually means it is a too much money. Nobody wants to lose this kind of money in oil and gas industry because everybody is there for a profit. Now coming to that, what kind of reasons that, okay, why this NPT happened in the oil and gas field? The most important reason is the equipment failure. Okay, means I cannot say that it is a moment, but it is one of the major problems, common failures like mud pump malfunctions, top drive failure, bottom hole assembly tools breakdown. All three I can show you. These are the pictures. This is the mud pump malfunction, mud pump operators, which is basically taking out the mud from the oil and gas field. This is the top drive failures means it is rotating the equipment, right, for the drilling rig and everything, so that we can penetrate into the earth and everything. So this, if this will get stuck or if it is getting failed, then there is a problem. And then if bottom hole assembly tools break down, so then you have to do the fishing, and it is taking hell lot of time basically. So these three are the major common things. Equipment failure, any kind of equipment failure, there you are paying a lot of money, a rental basis for the rig, and if you are not able to produce oil and gas from the subsurface, then it is a big problem. So equipment failure is the first thing. You can see that why it is there. Number two is well bore instability, that is stuck pipe. Stuck pipe means what? Well bore instability occurs when the rock around the hole collapses or become unstable, often leading to a stuck pipe. So your pipe gets stuck, then you have to fish it out. So this is again a big problem. So sometimes what happens, we are putting some mud on that particular thing to drill that into that, and chemical reactions between drilling fluids, shales, or high tectonic stresses are there. These are the major problems. Why? Because sometimes we will not able to improper mud weight, means like we are not able to put the right kind of weight on that. Because of that, it got stuck pipe and you have to do the fishing. And because of fishing, it's a worse scenario. Means like if it is a fishing operation, definitely try to understand you will lose a lot of money and there will be NPT. So that is non-productive time. This is the second kind of problem which you can see there. Then the lost circulation. Lost circulation happens when the drilling fluid flows into the formation instead of returning to the surface. Basically, the mud should come out, right? Then only that hole will get, when you are drilling an oil and gas field, you will try to drill a particular well. And if the mud will go into the formation, definitely there is a problem. Then you will lose circulation. And when you are doing this kind of work in a permeable zone, highly permeable zone, that is one of the major reasons why it happens. So that is again a one major problem, lost circulation. This is also a very important problem, human error and personal issues. So let's say the person who reached to that particular field, he did not have a proper certification. He is like not having these kind of proper certification which can do a work. Okay, then we have to replace that particular person. Miscommunication between shifts, somebody has to come, he has not come. Because of that, we are just sitting idle, we are not doing any drilling operation, and because of that the NPT happens. So these are the human errors and the personal issues. Because of that, NPT happens. And the weather obviously, sometimes uh, you know uh, high winds, heavy seas, or hurricanes, all these kinds of things, but these are moderate, I can say. But the topmost are like equipment failures, wellbore instability, lost circulation. All these are major. So if I try to give it a severity level, so equipment failure is moderate to high, stuck pipe very high, we have to do fishing a lot. Lost circulation is high, and human errors are variable. You can say that, okay, moderate to high, you can say. Weather is moderate. So because it is not in our hand. So we don't want to lose this kind of work. See, think about that particular rig, which is just a normal rig, and we do not know, okay, when will happen this equipment failure, when it will happen. You do not know that because you have a normal rig, right? You don't have any sensors on that. Now what we have done, we have put a lot of sensors into this particular oil and gas rig. Like, you can see drilling depth sensor, fluid pressure sensor, this pressure sensor, flow meter sensor, all kind of sensors we have kept there just to identify that, okay, is there any way that we can identify easily that, okay, this is going high and it may cause failure. So we can change that before time when our NPT is going to happen. If we get that sense into us, that kind of reading from a particular thing that, okay, the torque is going high, the RPM is going high, how can we reduce that? Okay, it is going how, let's reduce that. So we are putting a lot of sensors into the rig, oil and gas rig, and we are trying to reduce that. We are monitoring it on a continuous basis. Okay, when we create a monitor structure there on the oil and gas field, we will see easily that, okay, where the pressure is getting high, where is that fluid pressure is getting high or low, so we can easily maintain the things. These kind of sensors are giving us the data like RPM, torque, and everything, and through that we can easily maintain the NPT time, that, okay, it is going to happen. We can predict the things before it happens in the oil and gas field. And for that, I have created one use case in Python to just showcase you that, okay, how can we measure the this basically the NPT in the oil and gas field. Okay, number one important thing is the time date stamp, which is needed, because when we put the sensors there, it is giving us in every second what happened, what is happening there in each and every second. So that is the first feature for us to create that in the Python, to see that, okay, when the NPT will happen, where it is going up, where it is going down, and we can stop the machine, we can take that particular measure and we can work on that. Okay. Second thing is RPM, revolution per minute. So how fast the drill string is rotating. So NPT context, if RPM drops towards zero while power is still being supplied, the pipe is physically being braked by the rock, a primarily indicator of stuck pipe event. So let's say it is going downwards. RPM data is coming continuously from the sensors, right? And if it is going downwards, we can immediately stop that, because might be there is a stuck pipe event is going to happen. So this will give you the data, so you can easily see that okay, what is the RPM round per minute, revolution per minute happening there. Second thing is the torque. What is the torque? The rotational force required to turn the pipe. That is called torque, kilonewton meters. If in NPT context, if I say, think of this as a stress on the drill string. In a synthetic data, notice the jump from 15.1 to 28.4. This represents the pipe grinding against the side of wellbore, which actually leads to NPT if not corrected immediately. So this data is coming continuously from the sensors, like torque, which is the rotational force. If it is going from 15.1 to 28.4, you can easily understand that, okay, might be NPT can happen. Let's stop that immediately and see where the pipe is. And we can just put some, corrective measures there. And again, we will start this. And then again, we will measure the torque from the sensor. And if it is again going to 15, that is good. It is going high, then there is a problem. So this kind of things happens. Okay, next is like liters per minute flow in. What is the volume of drilling mud being pumped down into the hole? So in NPT context, we can say this is constant at 2500. This serves as baseline. If this stays steady, but other things change, we know the issue is downhole, not with the pumps. See, these kind of measures we have to take, and we have to get this data from the sensors. So which data I have told you? Was this the timestamp? Second is the RPM. Third is the torque. Then is the flow in liters. Then there is a flow out percentage, that okay, how much it's getting out. So if you see a drop from 65 to 40, it means 60% of expensive fluid is disappearing into the earth. That is a problem, and might be NPT happens. Hole goes dry. So you have to make sure that okay, it should be 65 basically. So the amount of mud returning to the surface relative to what sent down, we have to see that. And this again data is coming out from sensors only. So then pump press bar, this is the pressure required to push the mud through the system. If pressure spikes while flow is constant, you're likely to have a pack off. If pressure drops suddenly, you might have a washout. See, these kind of data are very, means like for the oil and gas drilling engineers, they can easily understand this, that okay, where is my pump pressure bar is going up or down, what kind of flow in or flow out percentage is there, what kind of torque is there, what kind of RPM is there. They can easily understand this kind of language. I am telling you just to take you through this, that okay, how can we apply a AI use case? Very simple. How can we apply a AI use case using Python, and where we can see that where is our NPT data. Okay, now coming back to our Python code. So I have created one Python code. This Python code is very simple. Pandas, NumPy, sklearn. So I have used only the simple libraries, and matplotlib I have used for the plotting a graph. So these four are the basically very simple libraries in Python. And I'm not going to explain this. You can go and watch it in any Gemini or anything. You will get the entire thing. Now, what I'm going to do, I will create a synthetic rig data. Means I don't have the real-time data, right? So I will just create it. What I have created, timestamp, which I have told you in the first part, RPM, torque, flow in, flow out, and pump pressure bar. These 5 things I have just generated. These are just, simple. I have given that, okay, let me create an NPT graph. And then based on this, I will do some calculation to understand that, okay, where is my NPT? Where is the non-productive time is there? So you can read this particular data in a data frame. Then you can create easily the delta torque, that, okay, what was their torque earlier and what is the current torque? So you can take that difference due to the time frame, that, okay, which time frame, what it is. And then anomaly detection. Anomaly detection will basically what will do, it will take all the features like RPM, torque, flow in and flow out, and pump pressure bar, everything it will take into consideration, and it will create an anomaly score. If your anomaly score is everything is in perfect fit, it will give you +1. And if everything is not in perfect fit, it will give you a -1. But -1, we have to see with all these kind of data, how can we correlate this particular data, the anomaly score from -1, and all these things like RPM, torque, and everything. So I have created a small calculation here by using Gemini. I'm not saying that I'm so great in writing codes, but yes, I have done that. So I have created one function here. If my anomaly score is equal to -1, means something is wrong with my particular data, it can give us alarm like potential loss circulation, impeding stuck pipe, equipment stop, or agar if everything is going good, else return me operation normal. So if else statement I have kept, if the float percentage is less than 80, if the torque is greater than 20 and RPM is greater than 0. See, torque is 20 and RPM is greater than 0. It is less than 20, it is greater than 0. Definitely this impeding stuck pipe problem will be there. RPM is 0, torque is less than 1, then it is equipment stopped and operational normal. So I will give this particular kind of condition to understand my data. This is my data, and I have given this particular condition. And then I will say, the okay, NPT status, just create a, I have just created a simply, chart out of it, that, okay, let's see how it is going to work. So you can see here, this is my timestamp. What is the timestamp? And this is the torque. And this is my NPT time. So you can see my torque is going good above 50, 24. When it is going 24, again, it is going down to 0. You can see that my NPT is getting here generated. Why? Because my torque is going down. It is going 15 is a normal thing. So it will go and continuously like this, then there is a no problem. But when it is going up to 24, immediately we have to see that, okay, there is something wrong in my particular data. We might get some NPT out of it because my torque is going that. So, real-time monitoring by using sensors can give us a lot of relief. So this is the cooked data which I have given. But generally, sensors will give you real-time data, and you can directly merge it with the Python or any other tool, and you can see this kind of data into your screen, that, okay, where my torque is, where my RPM is. So all these things will show you that, okay, this is the time. And you can see the formula which I have written here, that, okay, operation normal, event stop. So here it is saying operation normal at 8:01, operation normal, operation normal, operation normal. And here it is saying NPT event equipment stop. Why? Because my torque has gone down, 24. So here I have given this particular thing. You can see there, NPT event equipment stop. So you can see torque KNM is less than 1. Here my torque has gone to 0. That's why it is called NPT event equipment stop. So my anomaly score is -1 and my torque has gone below 1. That's why it is showing me this NPT time. So guys, this is just an example. How can we use AI, particularly in the oil field, and what kind of data we can see there, what kind of features which are important. So just remember this. If anybody will ask you what is NPT and how it is impacting, so just remember this, $38 million annually to the unplanned downtime. $38 million they are losing just because this of the unplanned downtime. So NPT, we have to cover oil and gas industry. Means they are looking at a very, they are spending a lot particular thing on this, because now what they are doing, they are putting a lot of sensors basically to get the real-time data, and they can plot it, and based on that, they can calculate about the NPT. So this is important, guys. So I just created this video because I was also going through some NPT. I'm not able to travel anywhere. It's very, tough conditions outside. We cannot drive, even flights are getting cancelled. So I thought, let's do something. NPT is important. I know that maybe you do not get everything out of it. Keep reading about it. Go to the Gemini, go to the Chat GPT, and put these topics like NPT and all, and start learning about it. And thank you for watching till end. Have a great day. Bye for now. Keep watching.